Want to gamble on when the water jet abrasive runs out? If you lose that bet, parts get scrapped. It costs you big bucks and lots of lost time. My name is Ryan Kelly. I'm a manufacturing and supply chain technologist for AMT. My job is to get tech into industry faster. Today, we're solving manufacturing challenges with bite-sized solutions. Give us 10 minutes and we'll give you a smarter shop. I'm here at the workshop at the Autodesk Technology Center here in Boston, where the team is exploring low-cost digital solutions to common shop problems. To help us literally weigh in on one of these low-cost solutions is Adam Allard, Senior Manager here at the workshops.
Hey Ryan.
Good to see you.
You as well.
So, you scrapped a 2-ton workpiece on this here water jet. How'd that happen?
Well, before we get to that, I'm going to tell you a little bit more about the water jet. The water jet operates on high pressure water. We have an intensifier pump in the other room that generates up to 94,000 psi, and it pushes through a 40,000 orifice in this tube. But the real magic behind the cutting is the garnet. So we have aluminum oxide that flows through the machine and actually gets intermixed with the water, allowing you to cut virtually any material that you put in front of it.
So what was the problem that you experienced?
Well, we had a 5x10 sheet of 2-inch thick steel that we placed on the table. The total cut time was about 3 hours. About the 2-hour mark, we heard that dreaded sound of water just billowing everywhere. The garnet ran out, and it ended up scrapping the part.
So I was looking at the hopper in the other room, and I noticed that it's a closed system.
Correct.
It's a pressurized unit. So when the water jet is running, you can't actually see inside of it to see what level that the garnet is at.
No, Ryan, there's no sight glass inside of the hopper. We cannot see inside.
Well, how'd you make it smart?
Well, let's take a walk over the hopper and I'll show you.
Great. So there's the garnet hopper, and I see you put it on a scale.
That's right, Ryan. We put the garnet hopper on a scale so we can measure the level by weight.
Well, I see the digital readout over there. How do you actually get that information someplace where you can take advantage of it?
Well, to explain that, I'm going to introduce you to Stephanie Pender.
Hi Ryan, hi Adam.
Hey Stephanie.
What you see here is a drum scale that's connected to a Tulip Edge MC device via USB. This is connected to our secure network that then communicates to our Tulip app, seen here. So this is an easy to use user interface with all of the information on how much garnet is in the hopper, and we have a 3-tiered system that basically gives us different colors for different levels of garnet. And this is connected to a light beacon as well that's attached to the water jet. So if the garnet level gets too low, it will email shop staff and they'll know to put more garnet in the hopper.
And then they'll also know if they're operating the machine if the level changes by the beacon light.
Absolutely.
Well, that seems like the exact type of solution that would prevent the problem that you experienced initially.
You bet, because it would save us that part scrapping and would save us a lot of time of actually having to stop and refill the hopper with unplanned.
So let's walk through the bill of materials. We've got the smart scale, it's connected to a digital readout. That's connected to the Edge device that's talking to the Tulip app and the beacon in the next room. Am I missing anything?
No, you got everything.
All in, what was the cost of the system? That's got to be less than the workpiece you scrapped.
Less than the part and the time needed to take the part off and put the new part on.
Well, how complicated was it to put this together?
It was relatively easy. It took us a couple days to integrate both the hardware and the Tulip app.
Did you have some background in IoT or programming before?
No, I don't have a computer science background. Tulip is a no-coding programming app, so essentially you're just selecting drop-down options of different colors and triggers. They make it super easy.
Well, thanks for walking us through the smart solution, Stephanie.
Sure, thanks for having me.
So you had the no garnet condition here that leads you to install the smart solution we saw in the other room.
Yes.
That means no more scrap workpieces on the water jet. But where do you go from here?
Well, because we can monitor the garnet levels via the scale, we know how much garnet's actually going into the catcher tank. When this gets to a certain level, we'll be able to call the environmental company to get it pumped out.
And I'm sure that means you know when to order new garnet as well.
Absolutely.
So are there lessons that you learned here that you're able to apply in other areas of the shop?
Positively, we're going to take some of the learnings from here and apply it to our shop in San Francisco. We have a 3D printer that uses gas for the process. We're going to take the same principles of monitoring over to that process.
If there's a physical component to your operation and you're not measuring it, take a step back and figure out how you could capture and communicate that data.
Particularly if it affects uptime and the bottom line.
There you have it. If it can run out before telling you to refill it, you need to connect it. That's how this smarter shop tipped the scales in favor of water jet uptime. We'll see you next time.